Hello, well, it is Tuesday, so we have a petrol shortage because of people panic buying over the fact there's a bit of a shortage of lorry drivers. And it doesn't affect me with the electric car, but it affects Mr. Chippy, who went home for the weekend at Bradford-ish, Shipley, wherever he is, and he can't get back, so he's booked a train ticket for tomorrow morning. So we've not been able to do any on the air tests, and I've actually been doing other things. Started an HMV stereo master, which you'll see it's the chassis which has come in. Recapping that, bloke's bought it from a second-hand shop, so that's on Mr. Chippy's bench. Anyway, we did the new old stock Midland 77805 DUK. Was it Sunday? Yes, it was. But we haven't been able to progress any further by doing an on-the-air test. Now, I'm mindful that the customer needs that back for a particular date, and if Mr. Chippy does make it on the train on Wednesday, we will start the tests on that day, because it will have to go back certainly by the weekend. So this is now skipping, because we've got a realistic 1005 in for service, which should be next, but we've got another one on its way, and it'd be sensible to do two at once. So we've also got a deviation meter in, and that will just have to hang around a bit. Audio line, the big audio line, with a very short power lead, which we'll of course rectify. And it's a rewirable type, so that's handy. It's come with a letter. Can you have a look and see if it can be repaired? Right, that's fair enough. Well, just for now, just in case it can't be repaired, instead of messing about with rewiring power leads, we will just get enough wire so we can put our beautiful crocodile clips onto this, so we can short them together, because we like doing that. So you probably saw me take 4 capacitors away off the top. There's two 470s there, these are Nicky cons. There's two 220s there. Every time I see one of these, I need to change those 4 capacitors. Now these are 39 years old. If I don't change them now, if they're not already faulty, well, they will be next week. And there's nothing worse. We learnt the hard way and ended up with a set coming back. And although it's not our fault per se, but you get this with motor cars, don't you? It's only had its MOT last week and now the clutch has gone. But this is for UK users. I appreciate other countries drive automatics, but in the UK you're only given half a driving licence if you learn to drive on a automatic car. So you get a full driving licence with a manual car, and therefore if you're seen driving an automatic car, people think you've only got half a driving licence. So it's kind of inverse snobbery. That's what that's about. What I was going to say is people then say, oh, the clutch went and it's only just had its MOT. Well, of course, the Ministry of Transport test is just to check that it's safe that day, not whether the clutch is about knackered. Oh, good grief. It's got a blue LED in the meter. I'm not going to reverse that, but talk about wanting to bang my head. So it's on permanent transmit as soon as you go into switching it on. So I don't know what's happened to that. I could just imagine somebody with a 1937 Rolls Royce and changing all the lights on the dashboard for blue LEDs. really goes through me, that. There are occasions when you've got burnt out, physically melted meters and that, and although I haven't had to do this, I have seen sets where the lamps have been replaced with LEDs, but they've been white LEDs to try their best to replicate what should be there, and I can understand that that can happen because the housings have melted, and you kind of having to glue gun something in just to make it look nearly right. Well, I might as well put the soldering iron on because I'm obviously going to need it. I hope those nuts aren't the cause. You know what? I'm really tempted to cut down those bolts. Anyway, it's still turning on into transmit. So I better connect the test instruments, otherwise it'll be transmitting into nothing. Eleven, 12, 13, 14, 15, 16, 17, 18, 19, 20. Turn it on now. Yeah, 2779, 200 milliwatts. And on high power, it's doing 3.4 watts. Right, we'll keep it on low power and see what's happened. So start by unsoldering this speaker. I'm looking at the time because it's one of my elderly parishioners have to do her shopping. She loves spending money at Marks and Spencer's. I prefer to get her stuff from Aldi and Lidl, but that's my way of thinking, not hers. This could be as simple as a short circuit capacitor on this subboard here for the microphone. But I wouldn't be that lucky, would I? So I wonder if it does it in PA mode. So I've got a standard replacement microphone. And what we'll do is to plug in our test equipment into the public address speaker socket. If I can find out which one it is, it's that one. Testing 1, 2. I think it uses the mic gain, doesn't it, on these? Testing 1, 2, testing 1, 2. Now I can hear the PAs on all the time. I can't remember whether it's keyed on these. It probably isn't. I think it just makes the contact in the mic and it works fine. So I'm going to change the 470 microfarads. The 220s have been changed at some point, but I'm going to change them again because that's my job, and for 40 something pence. It's not going to fix the set, but it's going to be the first one of the first things we need to do. Actually, I think we'll just go down looking at this. There's a cobweb there. This microphone keying it a bit further. So which is the mic pin, which is transmit? So if we get this chart, which isn't necessarily accurate, out, number 2. So according to this, so that way round, then transmit would be that. That pin there. So we'll turn it back on. We'll put it back into CB mode, so it's now going into transmit. So audio hot is that one. I wonder if it actually transmits any speech when it's doing this. Let's put our little monitor receiver on. Testing 1 2, testing 1 2. Yeah, as soon as I key the microphone, as in making the audio path through like we did with PA. You know, just in case they've bought it like this and I haven't got the whole story, I'm going to compare this with something we've got. And we'll just do this comparison and then we'll have to go. So, we've got a Uniden 200 here. So let's have a look. So the orange wire goes to the same place. The blue wire goes to the same place. The yellow wire obviously goes to the same place. That was very easy to find. And the black wire goes to the same place. So I'll look at the I'll look at what I can with the service manual. The trouble is the service manual we've got for the Realistic 2000, the fronts differ. So I'll look where on the board the transmit goes in, and I'll disconnect the wire, so it then eliminates there being a short circuit on that subboard. There'll probably be a switching transistor. Sometimes what people do, they try and wire up a power mic or something and they can blow it up, you know, so it can be sorted, but whatever there is, it will be sorted. Wonder why that one hasn't been sorted. Okay, we'll put it on one side again, stop the video, and I'll see you all later on. Right, so I've changed those capacitors. One of the ones which had been changed was a 470. One of the 220s hadn't been changed. They'd obviously had issues around the supply to the phase lock loop chip, which you get with the 220 failing. That looks like it's been changed as well. So we'll test those later on, but what I wanted to get to the bottom of was why was it into permanent transmit. So looking at the circuit diagram of the Realistic 2000, and I haven't got the best, oh, sorry, on the floor. I haven't got the best copy in the world. It's trouble when you're scanning a photocopy. Right, let's just zoom in on that. And now it's the phone ringing. That was my retired friend Bob. Although I'd love to hear from him, I'm in the middle of a working day, you know, and I can't take time off work like that. Right, so where were we? We're looking at it here, transistor 17. So I first of all popped out transistor 18, and it wasn't. That's fine. So I've popped out transistor 17. Now my logic here is we're going through the transmit line. Now it's a 5-pin DIN on the realistic, so it is obviously the pins are different. But we're coming from this line here, and I thought if this has had a voltage spike, you know, like supposing somebody's tried to put a wrong microphone on it with power on it or something like that, then what's it going to zap? So that was my first one, and it read fine. Well, the second one, transistor 17, is a 2SC1815, which to UK people is like a plastic BC238, which in turn is like a metal BC108. But we do stock them. So I've got the transistor tester. With that part missing, if I turn the radio on, it's no longer in transmit. So here's the Peak Atlas component tester. And it says short circuit on blue and green. So there you go. So it does say C1850, which is another point I'm going to come to. You know, when you're changing parts, where's my camera? I don't know where my camera's put. There we are. So I don't know whether that's going to show up. He's determined to go with the flat way on. It says C1815. Some of you may not know that when it's a Far Eastern piece of equipment and it says C something or B something or D something, it means 2SA, 2SB, 2SD. I have people emailing me saying, where do I get an A such and such from? Well, it's 2SA 1015 in the case of transistor 18. So anyway, I have fetched out of stock a new transistor. And that too says C1815 on it. So it's GR version. So I'm not going to, I'll put that in the bin so it doesn't end up being recovered. So I'll put the manual down for a moment. And I'll just check this works before I put it in. And then if there's a malfunction that causes it to fail, we'll know it started off working. I only use recovered parts when we have to use recovered parts. We do have nearly all the semiconductors in stock new. NPN bipolar transistor. So there we go. So we'll pop that back in. I'll return the camera to its normal position. And we'll put that in. Chop the excessive legs off. nothing worse than putting the case on and shorting something out. And now we'll power it up and hope. And there we have better plug the mic in. There we have no transmit on its own. So I'll just very quickly, I'm going to go for lunch, I'm very quickly going to put the signal generator on, and then we'll do servicing later on today. I'm just going to go to Spalding to pick up a valve top band ham transmitter. It's 1.6 megs from 1961-ish, which I bought off eBay. And this is when I'm glad I've got the electric car to use, because of this petrol shortage at the moment. Well, not petrol shortage, panic buying petrol shortage. I was in Morrison's yesterday doing one of the elderly parishioners shopping. She wanted toilet rolls, which she has every week. And I noticed there weren't that many left, so it looks like they were panic buying toilet rolls again as well. Obviously, petrol delivery tanker shortage causes toilet paper to run out. So these sets, I have to remember, aren't as sensitive as... Wow, that's miles off frequency. Oh, see RF gain down? Yeah. Not off frequency at all, the RF gain down. So that's 1 microvolt. So that's, yes, it's going to be alright. And on transmit, let's switch picture in picture on. So, which is high, I think we're in low power. That's interesting, I've got nothing coming out of it. So now this is working and the short's been removed, it isn't actually going into transmit. So we'll have to look further into what's happened there. Anyway, we're halfway there, aren't we? Right, I managed to find an original circuit for the... it was just helped because it's A3 size. So, once I changed the transistor, as you saw, we got no joy. In actual fact, diode 13 there, which is an IS 555, I didn't bother looking it up, I just finished one off a scrap chassis, isn't showing as... Well, oh, that's the wrong meter. Isn't showing as working properly. So it's quite possible that the short on the transistors damaged this diode. So it's coming up as unknown stroke faulty components. Now if we put that on the meter, see what we get. So we get under 1K one way. Yeah, so it's leaky. So was it the diode that went faulty and has caused the transistor to short circuit, or was the short on the transistor what's caused the diode to fail? Now what I've done as a precaution, that's that 220 microfarad capacitor that you must always change. No, 76 just there. And as a precaution, where are we? I have changed. That's the other one. That's one of the 470s. I've changed two others. That one. because if that went leaky, it would put a strain on that power rail. And change the one next to it at the same time. I mean, for the 16 pence they are, may as well. Oops, that's the manual on the floor. So now we're back to a working radio, which we just need to whip through and do a quick alignment on. So I don't think I'm going to have to go through the VCO. I'm going to do a check there's actually something about how it should be. But the that coil's not being touched, so help if there was somewhere to put the test prod. Where are we? That's the test point. So it's supposed to be a bit higher than that. Well, that's about right. Yeah, there's nothing scary on that. That's not being messed with. So we'll just go through the tune-up on that. May as well use the other manual while it's here. So manuals like this, you know how everything works, and as well as the limit specifications. So it tells us that the radio is supposed to do 3.4 watts is our limit specification. About like today, isn't it? Yeah, supposed to have 3.5 volts on test point 1, and that's exactly what we've got. So we're going to go through. I may as well use both the manuals I've got because it's going to be just quicker. So we'll make sure we're back on channel 20. I do hate this blue LED. L6. Oh, they do receive first. That's bizarre. 16, 15, 14, 13, 10. I've got my eye on the time again to pick that radio up I bought off eBay from Spalding. Got 10 minutes. I've put my electric car on charge. I don't normally charge it during the day. We rely on economy 7, but I didn't want to be caught short. Not sure where the normal trimming tool is. I hope this isn't too wide. It is too wide. It's there. Right, so have we got picture in picture? Yes, it looks like we have 3.5 watts. So we'll just whip through these, but make sure we're on peak. A bit gain there. A bit gain there. And then they say 10. Oh no, they do 12 and 10. That's 12. Now we want that bigger tool. We're about 3.6. We're above the limit spec. And there we have it at 4. As you can see. So now they want us to do Oh, I'm going back to receive again, mate. 4 watts on the RF meter. Oh, they want low power variable resistor 4. So low power, let's go into low power. It's 0.2. So variable resistor 4. Why would anybody adjust that to be lower? I don't get that. Anyway, it's now right. And so what's next? They want you to do deviation. I'm going to do transmit. We'll go back to 4 watts. And I'm going to do transmit meter, which is VR3. So just get myself in position with VR3, which is there. Let's see where it reads on the meter. It's supposed to be in the centre of that zone. I can't tell the colours because of the silly blue LED. And then they want us to do deviation. Where is it? 1, 2, 1, 2, 1, 2. Wallow. Well, I go to the foot of our stairs. It's wallow. 0.5 deviation. Let's listen to that on our monitor receiver. Testing 1, 2, testing 1, 2. Wallow. Well, unless there's a malfunction, let's see if we can bring it up. So deviation. It's the one I can't spot. No, there's a malfunction. Or my meter's not set right. No. It's 1.2 at full whack. Testing 1, 2, testing 1, 2. 1, 2, 1, 2, 1, 2, 1, 2, 1, 2. What if it's a faulty microphone? I mean, there could be something wrong with the insert. It sounded alright on public address though, I'm sure. But we'll get another mic out of stock, and tell you what, we'll come back to that. I've only got 8 minutes. We'll come back to that. So pop the mic back in. So apart from that, we've done transmit. So let's look over. I'll take this meter out of the way. We'll go over to the. I'll take the bench light off. We'll go over to the oscilloscope. Before we do that, I'll just show you the frequency. 2779124, which, considering these aren't adjustable, is pretty spot on for a 39-year-old radio. Now over to that oscilloscope. And let's look at that recovered audio from the detector circuit. So I'm going to put S9 on the signal generator. That's 100 microvolts. It's L19, I think, on these. It's going to be there, isn't it? Yeah. Right, see if that's maximum. No, we've been able to improve that. So that's going to help them a bit. Oh, let's just see. I've adjusted that, but I won't adjust anything else. Let's just see where the sensitivity is. So I'll put the bench light back on. And we'll just go over to that cyanide meter. Because they're not as sensitive as a lot of radios. So I did recap one and it became more sensitive, didn't it? There we go. It's on the 1 scale. Yeah, I mean that's great. It's 0.46, 0.46 microvolts for 12 decibel cyanide. And what we're supposed to be doing? Well, they quote 10 decibels, so we'll set it to 10. They quote 0.5, or that's 0.38. So there's nothing wrong with the receive. But we're still going to go through it anyway. So there's 4 decibels. Let's just whip through these. So it's 6. 6, 5, 4, 3, 2, 1. I prefer that the other way round. Let's put a bigger signal on for that one. Now you can't see those on a small signal. It's pretty spot on, that. So let's see where we are now for 12 dB. Yeah, 0.46 for 12 dB. Have I improved it? And 0.41. Anyway, it's excellent. So we'll just do the signal meter. So I've put S9 on, which is 100 microvolts for a CB in the UK. It's a bit lazy, as they would say. Bring that up to S9. Squelch. So I'm going to set the squelch to full. I'm going to put this over to the attenuator control so you can see where we are. So I want it to come in as 100 microvolts. $30, 100. It's one of those that never comes in, set totally wrongly. That's how we want it. Now we'll check the sensitivity at the other end. So I'm going to park the signal generator at 0.3 of a microvolt. That's now in standby. Turn the squelch down and set threshold. Switch the signal generator on. Let's see when it comes in. I hope it's better than that. Comes in at 1.4 microvolts. That's lousy. I'm just going to be more careful how I set the squelch. We'll just give it another go. Switch the signal generator on. Oh, that's better. So I can get the squelch to come in at 0.48 of a microvolt and to leave at 0.35 of a microvolt. So you've got to be, it's a bit like a lot of sets, the Cybernet sets don't have the best squelch in the world, and you've certainly got to be on the ball where your threshold is. So that's now set up correctly, so that's good. So that's it, we're back, we are back done. Just got to look into why there's that deviation. I'm going to disappear off to Spalding and in the electric car, and I'll be back in a couple of hours. Right, well, what time is it now? 6:45. So that did the Spalding thing. So let's see. Let's get out a new microphone. This should be a Uniden wired one. And let's see whether that makes the radio transmit some audio. And then we can button it up. Wallow. 1 2 1 2. 1 2 1 2. Wallow. Yes, it's the mic. So let's put our monitor receiver on. Hello, testing 1 2 1 2, testing 1 2, testing 1 2. Let's leave it at that volume level. Hello, testing 1 2. Hello, testing 1 2. I will just check mic gain though. Oh, mic gain's not at full. Okay. I'm a professional. Hello, testing 1 2. Right. Well, of course, business radios, which I'm used to, don't have mic gain. 1 2. There's nothing wrong with the mic at all. Might just sound better on my other one, doesn't it? We'll put that back in its box. Sorry to have accused you. As I was driving to Spalding and back, I wonder what it is wrong with that radio, which is low mic gain. It could be this preamplifier chip that's up the spout, and oh yeah, no, it's me with blowing volume control on the mic. Right, we'll reset the transmitted audio. Let's go over to that meter, and as you can see, we've now got far too much deviation with me having turned it up to volt. I knew that wasn't going to be right, so let's try it there. 1 2 1 2. It's just a little bit too much still. 1 2 1 2. That's all right. Max of 2.5. Testing 1 2. Testing 1 2 3 4 5. They're always a bit bassy, these radios, and those mics we have are a bit trebly, so it makes a better combination. But I'm not here to sell people microphones. We'll put the proper service manual away. We can put the scan of the service manual away because we're done. So I'll just pop the lids back on, and I may as well pause the video while we do that. I think I'm just going to clean up on the printed circuit board. Doing quite a lot of capacitors changed there. Where's Mr. Chippy's toothbrush? So I must remember to pick him up from the railway station tomorrow, or we'll have no more scratchy corner tests until he gets back. So this is what, we've put that Midland to one side. We're going to have to put this to one side. This dries pretty quickly. There's one up there, wasn't there? I still don't like those sticking out, but hey, that's not what's caused the problem. I'm not going to put the mic clip back on. I honestly don't like to see those. And some of these screws were wrong, and I'm not saying what we've got in stock is going to be right. I'm going to have to find some screws. So I'll tell you what we'll just do. We'll put in half the screws just so I can get on. We'll be mending that power lead with an inline fuse holder. Be able to dismantle that and repair that, which is going to be cheaper than him having a new one. I will get 2 screws in each side. Now, there's 2 grey wires, aren't there, on these to go to the speaker. So, although it shouldn't matter on polarity at all, it's not like it's stereo. Let's see if we can determine which one is the earthy one. Well, it looks like that one for a start. Yeah. So the one I've got in my hand is the Audio Hot. And the one I don't have in my fingers was the earthy end. See whether we can find two screws that will go in there. I'll just pop the power supply off while I'm turning it round and round, because I'll probably end up shorting my crocodile clips out. Not that it matters, but I don't need to do it if I don't have to. Right, there we go. So we'll unplug the test equipment. I'm satisfied it's working beautifully. Brought his transmit up. No idea what the deviation was. Right, we're now on an aerial. I'll just unplug the extension speaker. And of course I plug a mic in. One on a Roger. Just make sure RF gain's up. It's best if I do these in the working day, so there's lorry drivers and farm workers out there. I think you're all having the tea, you're watching telly. Anyway, it's back working. We'll do a scratchy corner test when I get Mr. Chippy back here. So that's nice. So it's just one of those things, just a combination of events, and there we have it. So there we have a very nice Audioline 340, is it? I can't even remember the model numbers. Yeah, the 340 from 1981. Back in the land of the living. I'm sure he'll be very pleased when I've mended that power lead, and we'll see you with some scratchy corner tests, well, hopefully when Mr. Chippy comes tomorrow. Thanks for watching.